Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is parallel courses part 3. So the challenge statement goes like this. You are given an integer n, which indicates that there are n courses labeled from 1 to n. You are also given a 2D integer array relations, where relations represent the previous course and the next course. So basically, let me explain this problem in my own words. So you are given an n courses. Some of these courses or all of them have prerequisite courses. Basically, you have to complete these prerequisite courses in order to take the courses. Okay, so the prerequisite courses should be done first, should be completed first. Okay, so then what the problem statement says is, so the prerequisite of each course is given by relations array represent prerequisite of each course. Which is given in the form of previous course and next course. Previous course denotes that has to be completed before the next course. So for example, if let's say you are given 0, 1 and something like this, 2, 3, then it means that 0 have to be completed first, only then you can go to 1. And for this particular relation, it means that 2 have to be completed first, then only you can take course 3. Okay, I hope you are able to understand what I am trying to say here. Let me disable this. Or to disable. Right. Then where were we? Okay. Furthermore, you are given a zero indexed integer array time, where time denotes how many months it will take to complete the I plus 1th course. So it is mentioned that all the courses are numbered from 0 to 1, numbered from 1 to 0, sorry, 1 to not 0 n. Okay, so and there is a times array where ith element in times array denotes time required to complete ith course, I plus 1th course. Okay, so it's a zero based indexing. Okay, so this is the problem statement. Then what you have to do is It is mentioned that you can start taking any course at any time, provided that the prerequisites are met. Okay. If the course that are required to as a prerequisite for a particular course are being done, then you can take up that course, and any number of courses can be taken simultaneously. Okay, and you have to return the minimum number of months needed to complete all the courses. Okay, and there is a note that is test cases are generated such that it is always possible to complete every course. Okay, so it will not be the case that you will not be able to complete the course. You have to tell what is the minimum number of time required to complete the course. Okay, for example, let's say we take this example. Uh, Let me change the background so that you will be able to see clearly. Okay, so let's say this is given to you, and these are the time limits in which the courses are expected to be completed. Okay, so it is very well understood that one is not depending upon any other course and two is not depending upon any other course. So it is very much logical to take up those courses which are not dependent on any of the courses currently. So currently we will be taking 1 and 2, and let's say we will use a queue-like structure. Okay, uh, the technique that we will be using here is BFS, breadth first search. Okay, breadth first search will be used. Those of you who are not familiar with what breadth first search is, I will be providing a link of article describing what breadth first search is. Okay, basically, first of all, you will be enqueuing the elements which are not dependent on any of courses which are not dependent on any of other courses. So how you will be checking the dependency? You will be taking a array called degree, and let's mark the indices 1, 2. So each index will represent index plus 1th course. Okay, so it will represent first course, it will represent second course, and it will represent third course. So first is having dependency 0. Also second is having dependency 0. 3 is having dependency 2. Okay, so that's the case. So let's mark the dependencies. So red color denotes the dependencies. It is having 0 dependency, it is having 0 dependency, it is having 2 dependency. Okay, these are dependencies. First of all, we will be taking 0 dependency courses. Okay, 0 dependency courses will be taken first. So we will be taking 1 and 2. Okay, now once you are done with taking 1 and 2, you will explore their neighbors. Okay, and what are the neighbors? So one is having a neighbor 3. A neighbor is nothing but a relation. It is a relation. So one is having a relation with 3. So what you will do is you will relax the dependency of 3. Let me change the color. Relax dependency of 3. For each of the course in the queue, You will explore its neighbor and relax their dependencies. For each course in queue, you will relax their neighbors and enqueue those courses in queue which are not having any dependencies after relaxation. After relaxation. Okay, and you will continue like this. Uh, how many data structures are being used currently? Let me change the color. I think this should be fine. So one, two. Now another structure that will be used to find the minimum time required will be distances array. Okay, so it will denote how many starting from the very first course that we take, uh, starting from the beginning of time, let's say, uh, what are what is distance or say time required to complete this particular course, or say this particular course, each individual course. So how we will be calculating what is the individual course that what is the time that the individual course will be completed in. For example, let's say three one was completed in 3 months and then three was completed in 5 months. So at present, if we see the distances array 0, 1, 2, and 3, okay, this will be representing 1, this will be representing 2, and this will be representing 3. Okay, so now currently if you take 1 and then 3, so your 1 will be taking 3 months, 2 will be taking 2 months. Okay, now 3, when you will explore 3 from 1 this way, it will be take 3 plus 5 is equal to 8 months. Okay, or let's say firstly you explore 2 plus 5 is equal to 7, 3 from 2, then it will take 7 months. Okay, then let's say you explore it from the first course, then you will see that this value is lesser than 3 plus 5. So you will update this value. Okay, so the number of months will be increased from 7 to 8. Since you cannot take up a course till the dependencies on it are completed, so it will take max of these two. Okay, that's why we will keep updating. So this is the distance array. I know it's a little messy, so in all I will be explaining again. Three data structures will be used. One will be queue, second will be, and let's say arrays, two arrays. One will be your what was the name of the array? yeah, degree array. And the second array that will be used is distances. At last, you will return the maximum value in distances. That will represent the minimum time required to complete all the courses. Okay, and this technique of taking zero dependency courses first, and relaxing their neighbors, and enqueuing them. Pardon me if some spelling is incorrect. I hope it does not affect your understanding of the solution. Enqueuing them in queue as they are completely free of dependency. This particular technique is called topological sort. Okay, those of you who are not familiar with topological sort, I will be also providing a link for this also. Okay, now let's see the implementation. This is the implementation. First, you will be making up a graph to show the relation between different courses. Okay, and then what you will do is you will find out. This will help you to find the zero degree. This data structure will help you to find the zero dependency courses and relax them while doing topological sort. Okay, and this particular queue will be used to do breadth first traversal of the graph. This queue will be used to do BFS in of graph of relations uh, in topological sort. Okay, for each of the node you will be taking its uh, here what we will do is you will be forming graph and the degree vector, forming the graph from the given relations array and degree vector to calculate dependencies. Okay, or say number of dependencies. Then after that, what you will do is you will be declaring another data structure. This data structure will be used to find the minimum time it will require for say ith course to be completed. Okay, and then what you will do is in topological sort, but then you will be enqueuing zero dependency courses first. Zero dependency courses first. Since they can be finished first, they are not dependent on any course. Then for each of the zero dependency course, in the queue, you will be relaxing the neighbors of that course. That is the courses dependent on the current course being explored for its neighbors. Okay, and as soon as a course reaches at zero dependency, you will be enqueuing it into the queue. Along that, what you will do is you will be updating the distance or say the time required to finish each course. Okay, along with the relaxation. At last, you will be returning the maximum time taking course. That will be the minimum time to complete all the courses. Maximum time taking courses courses uh, courses time will be returned. Okay, that will solve your problem. And if you're still having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer them. And I will try to make the code available in C++, Java, and Python 3. So thank you for watching. Thanks.